So this was the approach that with all this information, with all the communication, with all the cooperation, this is kind of the approach that we came up with. More than anything, whether it's our approach or it's another approach, okay, a sediment management plan is desperately needed for this area. We need a plan to manage the sediment, period, okay? So if I leave here today, no big deal, but I hope someone is going to be coming up with a plan to manage sediment, because as we saw earlier, there's no stopping it. So our approach was to come up with that plan. How could you create a management plan that is effectively dealing with sedimentation? The other thing we wanted to do is we wanted to look at this unique, innovative technology that we have that we think would be great for collecting sandy sediments from a river, and how we can incorporate beneficial reuse practices. Those two are really the things that we pride ourselves on. Innovative technology, beneficial reuse practices. Now, if you can capture sand from a river, you all of a sudden can create a commodity, okay? This is exactly what we're doing in Cleveland, Ohio. They bring us hundreds of thousands of tons or yards of sediment a year, and they say, Kurtz Brothers, commoditize this. Find a home for this. Do something with it so we don't just have to sit there with it and let it build up land. Well, that is exactly what we do. So Kurtz Brothers recycles this material and then provides it into the market for a whole slew of different beneficial reuses, and I'll talk about those a little bit later. But that needed to be incorporated into this plan, but not only in terms of, hey, we need to do this, but maybe let's build some new commerce out of this product. Finally, and this is kind of like my personal opinion, I firmly believe that if we did sediment collectors and we were capturing sand and we were building business models that then that sand can be reintroduced as commodities in other places, we then would have the ability to reinvest back into the sediment management plan. And maybe as time goes on, as innovation continues to grow, we can have some larger closed loop systems where maybe we can take the sediment direct from the Niobrara down past Gavin's Point. It's not easy, but it's not impossible. It's just costly. So if we're reinvesting into the project, maybe that's a goal down at the end of the road that we could then provide for this entire region. So what is this technology that I'm talking about? It's really simple, guys. I mean, I'm not an engineer, and I understand this. What I kind of always equate this to is a speed bump in the parking lot. A speed bump is there to slow down your car, right? Well, a sediment collector essentially does the same thing, only it does it with sediment. The way it works is essentially this is a 30-foot collector. The collector gets buried in the river where you only have about 18 inches of it exposed. So you really don't have to deal a ton with the threat of damming or boats being able to pass by. Our collector is in a part of the river where it's only 6 feet deep, and I can't see anything. I can never see the top of the bottom of the collector, but it's there. So really what I'm suggesting here is using the energy of the river, which is always there, that's transporting sediment, to let it go up, let it hit our speed bump, and then let it go into these grates on top, collect it, and then pump it to an area where that sediment can be recycled. The benefits of such is that it's extremely low operating costs, it's efficient and effective in the right system, customizable and scalable. So this is kind of a simple explanation of how the system works. But again, sediment's coming down. It's always coming down the river. It's going to hit the ramp. It's going to tumble up. It's going to go into a grate system. From the grate system, it's going to fall into a hopper. and then it's going to pump the sediment to a staging area where it can be reused. Common question I get is, well, what about the fish? Are you going to be sucking in fish into the system? No. The system is not a continually operating pump. Okay, it only fills up and it only pumps when the hopper is full. So there's not a constant sucking action, and I'm going to demonstrate that here in the next slide, if I can do this. So this is a video of how this works. Okay, so here the sediment is just kind of making its way up the ramp, and organics are passing right through it. Okay, so you don't see a huge suction effect going on, bringing down organics into the material. That was important for us because, we're commoditizing the material. We don't want organics in with clean sand. But then also this kind of demonstrates that, you're not going to be pulling in fish with all that suction action that's not taking place. But this is a demonstration of what it would look like in the water. So it's a long video. Okay. So the benefits, as I kind of just described them, you're going to selectively capture and remove sediment from a targeted region during regular flows and major storm events. These systems actually work really well during flow events, during heavy rain events. We get the most sediment that we capture in our collector in Ohio when the river is raging, because that's when you have your high sedimentation rates. From our estimates, okay, and I'm going to describe where the background information comes from. From our estimates, conservatively, we believe that we can reduce sediment from the Niobrara River by 60%. 60%. 60% sediment out of the Niobrara River is almost 1 million yards. That's pretty significant in terms of the sediment that's coming into the region. Other regional benefits? What would that do? It would help protect against flooding. It would reduce the impact and need for dredging. Dredging works. Dredging is a great way to remove sediment, but it's expensive. It's extremely expensive. You can monitor sediment. These systems are automated. They only turn on when they need to turn on. The whole system can help you track and manage what is actually happening with sedimentation rates. We can see if it's going down. We can see the movement. These systems allow for that. I don't even need to go to the last two, but it improves the environmental impact for both humans and marine habitat. Obviously, the people who are doing boating would much rather be boating in Yankton than they're doing in Niobrara River or in the Niobrara region, because there's just too many sandbars up there now. And then finally, the benefit is you all of a sudden have a very inexpensive commodity. So let me talk about commoditization here for a second, because that's always a big one that people want to know. Well, what are you going to do with the sand? Well, my question is, what are you going to do with the sand? Okay, you're all of a sudden sitting on, sand and gravel pits. You all of a sudden have a resource that, through some time, talent, and energy, you could be providing and making revenue and commerce right here. We provide sediment for a whole slew of things back in Cleveland, and some of them would be primarily the construction market, piping, subgrade, structural fill, land bank, land redevelopment, concrete. Had a meeting with a lady from the National Concrete Institute. She was interested in hearing about the sand that we have here. When I told her that we could potentially be pulling out 1 million yards of sand right here in Nebraska, South Dakota, well, she was interested. She was really intrigued by that. She's like, wow. And then she started telling me about other markets for sand, specialty products, traction coating, oil and gas market. Hey, don't you, right up north, isn't there a huge oil and gas industry? Sure there is. And did you hear the trends in the industry that actually oil and gas wants finer sand grain than the typical 2040 that they were used to? Topsoil agriculture, I can go into those too. We also use DOT projects, provide sediment for embankment, MSC walls, LSM, and other engineered fills. These are some opportunities that we use, and these are other opportunities that you could use. Okay? Again, no, it's something that a program would need to be put in place and would need to be constructed. Yeah.
Just a clarification, you said 1 million tons or 1 million cubic yards?
Cubic yards. Sorry, 1 million cubic yards.
Per year.
Per year. Every year. Every year. Cubic yards. Okay. So don't take my word for it. Okay. The U.S. Army Corps of Engineers from the Research and Development District in Vicksburg, a group called ERDICT, okay, they took this technology and they studied it, and they determined what the efficiency rates are, and they determined where this would be best used in. This is not Kurtz Brothers, this is not FOAT, this is the United States Army Corps of Engineers conducted that peak production rates on these units would be 100 cubic yards an hour. They can withstand extreme storms. They're not going to mosey on down the river. That was a big concern when we installed ours. You know, are these things going to stay in place? They are great for reducing total quantity of sediment, minimum maintenance costs, and they're really relatively inexpensive to deploy. What I liked primarily from this report was kind of the section I highlighted here. And it's got to be the theme that we need here for our sediment management plan. It's that by actively managing sediments at the watershed level, it is possible to drastically reduce sediment load to the area or channel of interest. That's what we need to do here. Okay? We need to be, actively managing these sediments in order to come up with solutions for them. Just to give you other third-party verification, I just had a webinar with the Kansas Water Office last week. They have these issues too, and they came up with this reservoir roadmap, a way to address issues in their reservoirs, and they determined that every dollar you spend in prevention of keeping that yard of sediment out of a reservoir, you're going to save $10 in removal costs. Another verification report that we had came from Colorado State University. They actually took the technology and they put it through a whole slew of tests that helped determine what the capture rates were for different grain sizes of material. And I'm going to kind of show you how I came up with our conclusions of the 60% here later. But again, these are not, the technology company coming up with these reports. These are third-party verifications on this stuff. So why will this work? Well, I talked about your young river, and I talked about it continues to meander, but you still do have some good areas where you have really established stream banks and bottoms. So opportunities do exist, do present themselves where something you built today wouldn't, the river wouldn't be going there down the road, 30, 40 years from now. You have this in place. You have these river bottlenecks that exist. A couple of them, I'm showing you one of them. This is just near Spencer Dam. This is all chalk rock. This is going to be there. This represents a potential site of a bottleneck that collectors could be really effective and efficient on. Secondly, I talked about your flow rate of your river. Again, if we try to get something that's consistently over 500, it depends on the sediment, obviously, but these are great. When I first got these, I was really encouraged to see the flow rates being this high. Finally, and kind of going back to that CSU study from Colorado State University, this is how I came up with this is how the technology company came up with the rates that we would be able to capture. Again, if you have 87% of the sediment based on a fine and medium grain size, that's pretty good material. And when you looked at what you would be able to capture with the Colorado State report, just using simple math, it's 65%. Now, that 100 yards an hour, that was actually for a smaller design. That's why when I said conservative, I'm really I believe that these are conservative numbers. Could be a lot higher, This is kind of what it would look like, okay? Don't get stuck in the location, but this is kind of what a system would look like. You would have a series of collectors. When we came up with our proposal, we used 4 50-foot collectors. to span the span of a river, you really wouldn't see these. Okay, again, they're underwater. The only thing you could possibly see is the top 18 inches, and that's if the water is really clear and it's really shallow. But the collectors would pump material to a station that would then pump the material to a receiving area where the material would then dewater, and really that material would then need to be managed as a commodity and either make its home there, but hopefully turn into a commodity which then you can reintroduce and then keep building back airspace and your lifespan that you would have on these locations. We are not done concluding where the best site is, okay? That work still needs to be done. In order to really do that and do that properly, you need to do groundwater studies. You need to understand what is going on in the area that you would be pumping material to, okay? That's absolutely critical to do. So these are some possible locations. Just downstream of the Spencer Dam, it's a really good location because of the bottleneck, as I just described. But then closer to the confluence, there's another region that also has kind of it borders along Highway 14, and it's more established. You do have that chalk rock base. Again, we're looking for things that are going to be there for decades to come. That's another good location. It actually could serve multiple purposes being that close to the confluence.